Hi, everyone. Welcome back to a brief look at the assignment and division operators that we have in here. And then these will kind of cover up the basics of your relational algebra. The assignment operation is just a convenient way to store a query, similar to what a variable expression is as well. So they must always be made to a temporary relation variable. But essentially, we can store something like select out of my relation instructor. All instructors with salary over 40,000. And then E2 as well can be stored as this one. And then we can create a new relation off of these two where we say assign E3 to relation of E1 and the union of E2. So essentially your assignment operation, very similar to what we've done with variables before in other coding classes. Instead of using an equal sign, we'll use a left arrow where it's pointing at the variable for it. You'll see this if you're doing RStudio and SQL code later on. When you create variables, you don't do the equal sign, you'll do the left arrow for us, okay? So in this relation, we just simply rename our assignments that we're doing into each of these, and then we have an output where we union them. A division operator is a little more complex, but R divided by S will produce tuples from the relation R that all their extensions on the relation of R and the intersection of S with tuples from S exist in R as well. So if I do my R divided by S, it will result in 98988 because these are the only courses that exist in my department name of biology that the students have taken here, okay? A further example here of this talk about this division operator is that it can be rewritten here as E minus or E subtraction from E2, these two areas, or the intersection of these two, okay? So to actually go through this here, if we have our these two databases that are somewhere else there, my first interaction is projection of the intersection between R minus S, so these two that exist by themselves inside of here. So I'm going to result with E1 with my two IDs of the two students I have. My second interaction that I have here is going to produce the projection of R minus S, and then I'm going to take the Cartesian product of my previous relation that I got from here. I'm going to times that by my S relation. I'm going to subtract that from the projection of the join of R and S. So you can see here now that this division operator is doing a lot more than just a simple subtraction operation, but it's going to be synonymous to this as well, okay? So what we're doing here is we're getting all the combinations of students in biology courses in our first R that's right here. And then we're also going to be taking the students who have taken a course in the biology, sorry, it's a typo, but essentially all the combination of students, the Cartesian product, and then also the resulting students that have actually done it there. So we'll get a bunch of different combinations here, and then it results with people that have actually taken it. And what we get at the end of that projection is going to just be the 9899, similar to what we saw earlier here in our previous slide there, okay? So again, these division operations are hiding a lot of what's going on beneath it. When you're doing this actual work on the SQL code, when we get into that later, you won't really need to worry about doing these Cartesian products there for us, but it's more so just making sure that you're aware of what's going on in the back end here, okay? So for one more operation, division operator example, we're going to take a look at what this looks like intersected with names. So if we read through this too, this is the same formula as what we had in the last slide as well. What we're essentially saying is that from my relation reads, select, or excuse me, project the name of everyone that has ever read anything in here. So again, that's all the population. From this projection, get that relation that we have there, so everyone, and get the Cartesian product of every newspaper. So that's going to be similar to what we had back in E2.1 with all these IDs to each course ID. Subtract that, subtract everyone's Cartesian product from the individuals that have actually read the newspaper themselves. So we could say, take the name of newspaper. Under join, again, this needs to exist in both of them, right? A join results in people that have existed in both relations. So again, this is our little join. And so when we write these two E1s and E2s, we could say reads divided by newspaper is going to be equal to the E1 minus E2, which is the intersection of those two. And excuse me, this will result with one person, that is Alice there. Okay, so this division might be a little heavy with the, and might be a little complicated looking too, but the idea that we want to use the division operator for is that if you want to get a combination of everyone who's taken these biology courses and the students have taken them, you can use this approach here. You don't need to actually do these Cartesian products for us. You just need to do the relation 1 divided by relation 2. And then again, you could say something where it's along the lines of return the name of all persons who read all newspapers. So if you're given this type of question that says, try to find everyone that has taken every biology class or every computer science class, you can use the division operator to help you achieve that goal.